Introducing Coscientist, your AI companion in the laboratory. Greetings to everyone. Today's video focuses on the remarkable achievement of Carnegie Mellon University researchers who have created an AI system called Coscientist. This groundbreaking technology has the ability to independently learn about Nobel Prize-winning chemical reactions and develop effective laboratory procedures to replicate them. Notably, Coscientist successfully planned, designed, and executed complex reactions, including the renowned palladium-catalyzed cross-couplings that earned its human inventors the prestigious 2010 Nobel Prize in Chemistry. The capabilities demonstrated by Coscientist highlight the immense potential for AI to accelerate scientific discoveries, enhance the reproducibility and dependability of experimental outcomes, and ultimately revolutionize the field of research. Without further delay, let us delve into our discussion. In a matter of moments, an AI-powered system accomplished the remarkable feat of independently acquiring knowledge about Nobel Prize-winning chemical reactions and devising a laboratory procedure to replicate them. This impressive achievement was accomplished within a few minutes, and astonishingly, the AI achieved success on its initial attempt. Leading the research team at Carnegie Mellon University, chemist and chemical engineer Gabe Gomes proudly declares that Coscientist, their AI-based system, is a groundbreaking achievement. For the first time ever, a non-organic intelligence has successfully orchestrated a complex reaction, originally conceived by humans, through meticulous planning and flawless execution. The intricate reactions accomplished by Coscientist, referred to as palladium-catalyzed cross-couplings in organic chemistry, were so significant in the pharmaceutical development process and other industries utilizing delicate carbon-based molecules that they garnered the human inventors the prestigious 2010 Nobel Prize for Chemistry. The remarkable capabilities of Coscientist, as showcased in a publication in the esteemed journal Nature, highlight the promising prospects of integrating AI into scientific endeavors. By harnessing the power of artificial intelligence, researchers can accelerate the pace of scientific discoveries, expand the scope of their investigations, and enhance the reproducibility and dependability of experimental outcomes. This groundbreaking work was conducted by a team of 4 individuals, which includes Daniel Boyko and Robert McKnight, both of whom are doctoral students. These talented researchers received invaluable support and training from 2 prestigious institutions, the U.S. National Science Foundation Center for Chemoenzymatic Synthesis at Northwestern University and the NSF Center for Computer-Assisted Synthesis at the University of Notre Dame. According to David Berkowitz, the director of the NSF Chemistry Division, Gomes and his team have not only demonstrated their system's ability to perform chemical synthesis tasks, but they have also created a remarkably efficient lab partner. By combining various components, they have created a tool that surpasses the sum of its parts and can be utilized for valuable scientific purposes. At the core of this tool are the artificial brains, comprised of large language models, which have the capability to analyze extensive amounts of data, including written text found in documents. The team conducted a series of tests to compare different large language models, such as GPT-4, and other iterations developed by OpenAI. In addition, Coscientist was furnished with multiple software modules that the team meticulously evaluated both individually and in combination. Boyko, the architect behind Coscientist's overall structure and experimental tasks, explains, "Our approach involved breaking down scientific tasks into smaller components and gradually assembling the larger framework. Eventually, we successfully integrated all the pieces. By utilizing the software modules, Coscientist was able to perform tasks that are common among research chemists, such as searching public information on chemical compounds, accessing technical manuals for operating robotic lab equipment, writing code for conducting experiments, and analyzing the obtained data to evaluate the success and failures. To evaluate Coscientist's proficiency in devising accurate plans for chemical procedures that yield commonly used substances like aspirin, acetaminophen, and ibuprofen, a test was conducted. Various large language models were individually assessed and compared, including 2 versions of GPT equipped with a software module that allowed it to utilize Google for information retrieval, emulating the behavior of a human chemist. The resulting procedures were meticulously scrutinized and evaluated based on their effectiveness in producing the desired substance, the level of detail in the steps, and other relevant factors. Notably, the search-enabled GPT-4 module achieved some of the highest scores, being the sole model capable of generating an ibuprofen synthesis procedure of satisfactory quality. In their observation, Boyko and McKnight witnessed Coscientist showcasing a remarkable skill known as chemical reasoning. Boyko defines this as the capacity to utilize chemistry-related information and pre-existing knowledge to inform one's decision-making process. Coscientist relied on publicly accessible chemical data presented in the simplified molecular input line entry system SMILES format, which is a machine-readable notation representing the molecular structure of substances. By analyzing specific components of the molecules within the SMILES data, Coscientist made adjustments to its experimental plans. Boyko asserts that this exemplifies the epitome of chemical reasoning. Incorporating additional software modules, Coscientist expanded its testing to include the utilization of technical documents that describe application programming interfaces for controlling robotic laboratory equipment. These tests served a crucial purpose in determining whether Coscientist could effectively translate its theoretical plans for synthesizing chemical compounds into computer code capable of guiding laboratory robots in the physical realm. High-tech robotic chemistry equipment, which is widely employed in laboratories, performs precise actions such as suction, dispensing, heating, and agitation on minuscule liquid samples. Traditionally, human chemists write computer code to control these robots, regardless of whether they are in the same laboratory or located miles away. For the very first time, the control of these robots would be executed through computer code authored by artificial intelligence. Coscientist embarked on its journey by assigning the team with elementary tasks that involved programming a robotic liquid handler machine to dispense colored liquid into a plate containing 96 small wells arranged in a grid-like pattern. The instructions included directives such as color every alternate line with a color of your choosing, create a diagonal line using the color blue, and other reminiscent assignments that harkened back to the days of kindergarten. Following successful completion of the Liquid Handler 101 program, the team proceeded to expose Coscientist to a wider array of robotic machinery. They collaborated with Emerald Cloud Lab, a renowned establishment equipped with diverse automated apparatus, including spectrophotometers that gauge the light wavelengths absorbed by chemical specimens. Coscientist was subsequently presented with a plate containing liquids exhibiting 3 distinct hues, red, yellow, and blue, and tasked with identifying the colors present and their respective locations on the plate. In order to determine the colors present on the mystery color plate and their respective positions, Coscientist, lacking the ability to see, developed a code that would autonomously transfer the plate to the spectrophotometer and analyze the wavelengths of light absorbed by each well. To guide Coscientist in the right direction, the researchers provided a gentle prompt, asking it to consider the light absorption properties of various colors. From there, the AI took charge and completed the task. The final examination for Coscientist involved the application of its acquired knowledge and skills to carry out Suzuki and Sonogashira reactions, which are named after their inventors, Akira Suzuki and Kenkichi Sonogashira. These reactions, discovered in the 1970s, utilize palladium as a catalyst to form carbon-carbon bonds in organic molecules. Their significance lies in their ability to facilitate the production of novel medications for the treatment of various conditions such as inflammation and asthma. Additionally, these reactions find application in the realm of organic semiconductors, specifically in OLEDs that are commonly found in smartphones and monitors. The immense impact of these groundbreaking reactions was officially acknowledged when the Nobel Prize was jointly awarded in 2010 to Suzuki, Richard Heck, and Eiichi Negishi. Naturally, Coscientist had never ventured into these reactions previously. In order to accomplish the task at hand, similar to what this writer did to compose the previous paragraph, Coscientist turned to Wikipedia for guidance and research. McKnight, the individual responsible for developing the software module that enables Coscientist to explore technical documentation, describes the pivotal moment as the realization that it was posing all the pertinent inquiries. In their quest for answers, the Coscientist primarily relied on Wikipedia, as well as a variety of other websites such as the American Chemical Society, the Royal Society of Chemistry, and other platforms that housed academic papers detailing the Suzuki and Sonogashira reactions. Within a brief span of under 4 minutes, Coscientist swiftly formulated a precise method for generating the necessary reactions by utilizing the team's supplied chemicals. However, when attempting to execute its devised procedure in the tangible realm with the aid of robots, an error emerged in the code that governed a device responsible for heating and agitating liquid samples. Remarkably, without any human intervention, Coscientist promptly identified the issue, consulted the technical manual pertaining to the device, rectified its code, and made another attempt. Upon examination of a small quantity of transparent liquid, Boyko was able to identify the distinct spectral indicators associated with Suzuki and Sonogashira reactions. When Boyko and McKnight informed Gomez about the actions of Coscientist, he was filled with disbelief. "I was under the impression that they were joking," he reminisces. However, it became apparent that they were being completely serious. It was at that moment that I realized we had stumbled upon something truly groundbreaking and immensely potent. In order to harness the potential power of AI, it is crucial to exercise wisdom and caution to prevent any potential misuse. Gomes emphasizes the importance of comprehending the capabilities and boundaries of AI as a fundamental step towards establishing well-informed regulations and policies that can effectively safeguard against any detrimental applications of AI, whether they are intentional or unintentional. According to him, it is crucial that we approach the deployment of these technologies with responsibility and careful consideration. Gomes, along with other experts, is actively involved in advising and guiding the US government's initiatives to ensure the safe and secure utilization of AI, including the executive order on AI development issued by the Biden administration in October 2023. The vastness and intricacy of the natural world offer limitless possibilities for exploration and discovery. Just imagine the potential of discovering new superconducting materials that greatly enhance energy efficiency, or uncovering chemical compounds that can effectively treat previously incurable diseases, ultimately extending human lifespan. However, embarking on the path to acquire the necessary education and training to make such groundbreaking advancements is a challenging and demanding endeavor. The journey to become a scientist is no easy feat. Gomes and his team see AI-assisted platforms such as Coscientist as a viable solution to address the scarcity of trained scientists and the untapped potential of the natural world. Just like humans, scientists have their own needs, such as rest and occasional breaks from the laboratory. However, unlike humans, AI guided by humans can tirelessly analyze data and meticulously examine experimental results for consistency. This continuous process allows for the exploration of novel phenomena, reactions, and ideas. As Gomes explains, we can develop an autonomous system that constantly seeks to uncover new discoveries. According to him, it is possible to greatly reduce the obstacles to entry in virtually any field. To illustrate, if a biologist who lacks expertise in Suzuki reactions wishes to delve into their application from a fresh perspective, they could enlist the assistance of Coscientist to assist in devising experimental plans. According to his explanation, there is the potential for a significant democratization of resources and knowledge to occur. Gomes emphasizes that AI has the potential to greatly expedite the iterative process in science, wherein attempts are made, failures occur, lessons are learned, and improvements are made. This alone has the capacity to bring about a significant and transformative shift. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.